Okay, Assalamualaikum and good morning.
Good
Okay,
morning, Doctor.
Good morning,
okay.
Doctor.
Morning, Doctor.
So today we continue with chapter 4, example 11. So I think you are in the first sem or second sem? Second sem or fourth sem?
Second.
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 You already learned about the RC circuit, second order.
Yes.
Okay, so you know what is this formula, right? This is basically how to calculate the charge. Okay, when you have RC circuit. Okay, so you try to understand the formula and you have to try to code the change of charge from 0 to 0.5 second. So this is the problem. So, and the algorithm will stop when the charge is 2 unit. So this is the problem. You have to do a coding using while loop. Okay. So the first coding is, so you have to set the constant. You can see here. Okay, the constant is voltage is 9, resistance is 4, capacitance is 1. So you just set the constant value. So because you want to start from when you're using while, okay, if you're using for, you no need to do this. But if you use while, you have to set the original, okay, the initial value, which is Q. Okay, Q is 0. Also time is 0 and N is 0. You have to set the initial value. So you the coding stop when the charge, okay, when the charge is reach level of 2 unit, means that while Q is less than or equals to 2, you have to do the looping. So you calculate the charge. This is the formula. Okay, and this one is basically, okay, this one is just to store the charge and time value. Okay, this is how you save the data. Okay, Q and, okay, this one is basically the location of the vector equals to the calculation. This one also, for the beginning, t is equals to 0, and then you have to step up the number. For the time, you have to t plus 0.5. So means that the time change for 0.5 second. And for n is the index. Okay, for index you have to add because you want to save at the next location. So n equals to n plus 1. Okay, that's why you have to put this, and then it will loop until the Q reach more than 2. Okay, after Q more than 2, it will end the simulation and will display the number. Okay, and number to string, this one make sure you know. If you have unknown here, okay, if you want to display the text here, you have to convert from number to string. So the output will get this. Okay. Why we cannot use t? Okay, because t is not integer. When it comes to the location of the vector here, you need to have an integer. Means what? 1, 2, 3, 4, 5. You cannot have 0.1, 0.2. There is no location of 1.1, 0.1, 0.2, something like that. That's why you need to have 2 parameter. Okay, next, example 12. Okay, if you look here, this one is the compound interest. Okay, remember the B multiplied by A 1 plus R power of N. So remember back that formula. Okay, last time we used the array. Okay, vectorizing. Okay, so right now we use for loop. Okay, so basically R is the constant here. Okay, and this one is the A. Okay, and because we want you want to use a nested loop. Okay, nested loop basically you have loop within the loop. So you have two for 4 and 4. So if you look here, for the outer 4 is the A. Okay, the initial value, initial investment. So 100, 500 and 800. Okay, so you have to display A. What is A? Okay, and then you do another loop for number of years. So n equals to 2 until 10 with the step of 2. So as long as it doesn't complete, it will run and run. So this one just display the result. Okay, let me show the code. Okay, is you can see here. Okay, this one will print this one. Okay, and this one will print this. Okay, the first one is just to show that it is within the A. Within the what is the A. Okay, just to show what is the A, and then next one is display the year and the calculated. Okay, the calculated value B. Okay, try to understand how to they get this. Okay, and also be careful. For example here, this one, okay, multiply by 1000. This one is is kilo. So make sure your answer is multiplied by kilo. Okay. So next example. Okay. Before this is the example of nested for a nested loop, means that there are loop within the loop. Okay. Now, how about the continue statement? So basically, continue statement is just to skip. Okay. For example, you have a statement here. Okay. You don't want to continue. You want to move the vector to the next one. You just use continue. Okay. So continue past the control loop to the next iteration. Okay. And skip the remaining statement. Okay. You can use the continue. Okay. For example, here is for n is equals to 1 until 50. So means that the n is 1 until 50. Okay, 1, 2, 3 until 50. And then it check mod is the remainder. Okay, you know, if you divide, for example, you divide 8 divide by 5, you get remainder 3. Okay, 1 remainder 3. So if you do this, mod is mod, for example, mod 13. Okay, mod 13 7 means then 13 divided by 7. So the answer for mod 13 7 is 6. Okay, so it is just remainder. Okay, so if mod n 7 is not 0, okay, here is 1, continue means that is skip. Okay, doesn't go here. Okay, it will not print the division. Okay, but if the mod is 0, means that the number that can be divided by 7 is 0, means that it will not run this and it will display this. So basically this is the coding on how to determine the number that can be divided by 7. Okay, so this is the function of continue, just to skip the operation. Okay. Okay. The another part within the loop is break. Okay. So continue means that you skip. Okay, one iteration. You skip only one iteration. For example, you currently n is 7. Okay, you run 7, then you just goes to 8 without finishing all the code. But for break, you just break everything. So instead of just keep the iteration, you just end the loop. So that is the function of break. Okay. So I give you example here. Okay, this is a guessing random number. Okay, if you can see here, okay, x is the random number. Random number, randy means the integer from 1 to 6. Okay, randy 6 means that you can it will choose a random number from 1 to 6. So n is the equals to 0. So remember, when using while, okay, you cannot count the iteration. So you have to put a n first equals to 0, and then you have to add within the coding. Okay, this one is the input guess. Okay, input guess the number. So basically you have to insert a number. Okay, so it will store in the guess variable here. And then of course you have to add n equals to n plus 1. Okay, just for the iteration. And if guess is equal to x, okay, if your guess number is equal to the random number you created, okay, it will display you get the answer, right? And at the number of try, okay, here is the number of try n. Okay, you have you write break. Okay, when you write break, automatically it will break out from this loop. Okay, while one means that it always looping. Okay, so if you don't want to do looping, remember you have to write 0 while 0. Okay, while 1, 2, 3, 4, 5, this one is true. Remember, everything that non-zero is true. Okay, so after it break, it will go this. So you can try this. Okay, instead of random number, I just put a pi. So easier to see the simulation. Okay. Okay, I think this one is in the chapter. I don't remember what chapter, but this is called a breakpoint. You can, when you do simulation, you don't want to run it continuously, you can press at the number to pause. So you run, okay, you can see here, okay, it running. So step, it guess, okay, guess the input, for example, 4. Okay, you step it, okay, enter. So automatically n will be updated from 0 to 1, and then okay. Oh, okay, sorry. This one. Okay. So for example, I put insert 4. So at this location, you can see that 4 is not 5. So your guess is 4. X is 5. So it will just skip. Okay. So again, if you run again, for example, it's 5. Okay. Enter. So you can see that guess is 5. Okay. X is 5. It will goes here. Okay. It goes. And then display this. Okay. Display it. Okay. You can see the arrow. It will run the break. Okay. Automatically, it will go out from the loop. Okay. This is the function of break. Okay, I think that one is simple. How about the vectorization for loop? Okay, as I mentioned before, for loop is inefficient. Okay, in terms of computing time, it takes a long time to compute. So in order to if you have a problem that can avoid for loop, try to use it. Okay, in the test or exam, sometimes they give the problem in for loop, you have to convert it to vectorization loop. This one is just a recap. You already learned this. Okay, I give you example. Okay, this is the example 9, which is the compound interest. Okay, calculate B equals to A 1 plus R power of N. So you can see here, you have multiple A value. Okay, as mentioned before, you have multiple A value, you have multiple R value. So you use for, okay, instead of double for, okay, you can see here, this is the code, okay, this is the double for I mentioned before, okay, you instead of using double for nested loop, okay, loop within the loop, you can use this one, okay, you can use this only one loop, which is much more efficient. So you just use the dot. Remember in chapter 2, okay, in chapter 2 or 3, so you learn about multiply. Oh, this one doesn't use this. So this one use vectorization. Okay, you can see here. 1, 2, 3 means that this one is for row 1, 2, 3. Okay, you take this value and n divided by 2 means that the location of this. Okay, so let me show you in the movement of the code. So of course you sign A first and R. A is the vector here. Okay, 100, 500, 800. So for loop here, okay, for n it is equals to 2. Okay, so right now n is equals to 2. Okay, n is equals to 2. Okay, so what it means that 1, 2, 3. Okay, means that row. Okay, row to the row is row 1, 2, 3. And n is divided by 2 because this is step of 2 and start with 2. So remember the location is to be integer, that's why it become like this. So 2 divided by 2 is 1. Means that in the column 1, okay, n is 2 divided by 2 is 1. Column 1, row 1, 2, 3, you use this formula A multiply by this one. So this one is a matrix. Okay, you just multiply this and okay, you get B like this. So you get this for A, the first A. Okay, just play around with the location. So next B change from 2 to 4 because your step is 2. Okay, so become 4. Okay, and then run this. Okay, of course, 4 divided by 2 is the location row 2. And again, 1, 2, 3. Okay, this one is because you have 3 data. Okay, run again. Okay, right now B is something like this. After you run it, it will store at the second location, second column. Okay, so same as the next part, it will go like that. So basically, it's just manipulating the array function. Okay, instead of using nested loop, you just only need one loop. Okay, you use vectorization for loop. Okay, basically this one is much more faster. Okay, avoid for loop by array operation. So you remember the mesh grid. So you can use a mesh grid function to avoid for loop. Okay, this one you use array operation. Okay, remember the dot. Okay, like I said before, you can either use a vectorization, okay, or use a dot multiplication or array operation. Okay, how to do this? So for example, here you have A, the same problem. A is this one, and N you have 2 until 10 with the step of 2. R is here. And remember, you create a mesh grid, okay, to create an array, a repeated array. So you have N and A mesh grid of this. So basically, it will create something like this. Okay, you have 2, 4, 6, 8, 10 for N, but it will repeat 3 because you have 3A. Okay, same as here. Okay, you have 100, okay, 100, 500, 800. So it will repeat 5 column because you have 5 number here. So something like this. Okay, you use mesh grid to create a array. And then you multiply array using a dot. Okay, remember the dot multiplication? Dot here. Okay, automatically it will calculate everything. Okay, so it is much more faster actually. But it is a little bit confusing because if you don't familiar with the mesh grid, it is quite difficult to multiply. So try to understand how to do this. Okay, I give you example 17. Okay. Okay, what is based on result? Okay, this one is just to test the simulation time. So you see here, it is tick and top. Okay, tick and top means that it will test the operation time. Okay, how long does it take to simulate this code? Okay, from tick to top. Okay, this one also tick to top, just to compare the mesh grid, okay, the array operation and the for loop. So the same for the same problem, okay. A is, instead of we set it, you use a random number, okay. Let me copy this. So I run this. You can see that A will be create this, okay, a random number from, okay, 1000 to 10,000, okay, 10,000 to 1,000 to 10,000, okay, random number created from 1,000 to 10,000. So one, okay, let me check. I forget what it means. So if you have problem with the coding, you just search using Google. So you just met, okay, you can use Google to find the answer. Okay, sorry, my internet is not okay. So random number, you can see here, n is, what is n? N is the number of array of data. So basically for this one, if you want to create a 2 row, okay, for example, you create 2 row, you run this, it will create 2 row, okay, number from 10,000 to 1,000 to 10,000. So that is how you create the number. So run again, it will create the constant here, okay, you create until, okay, a lot of years. So from 2 years until 20,000 years. Okay, R is constant. Okay, and then you do a mesh group, mesh grid. Okay, and as well as this one from example, previous example. Okay, and time 1 and time 2 just to save the processing time. So if you look here, if I run this, okay, it will take time to complete because it is have a lot of number. Okay, but this one is the result, example result. So you can see that the array, okay, the what you call the mesh grid, the array operation is faster compared to for loop. Okay, so if you want the coding is to be fast, you have to choose the array operation. Okay, so make sure you know how to convert this to this and how to convert mesh grid to the for loop, because sometimes question will ask how to convert both of it. Okay, try to look at the test and exam example I give you. Okay, if you want to know how what type of question will be asked, and you cannot open the MATLAB to answer it. Okay, so example 18. Okay, also avoiding loop and decision statement. This one using logic. Remember the logic? I think this one I already showed before. If you have logic, you just multiply with the value. Okay, you can see here. Multiply, and you have to sum everything. So you will get the answer. Okay, this one I already mentioned in the previous chapter. So I will not explain it more. I try to do the revision on this. Okay, that's it for this chapter. Okay, for the next part is we do a drill. So I will divide you into a 4 group. Okay, 4 group. Wait, I think 8 group is much more better. 8 group because I think you have a lot of member right now. Okay, I will divide you to the 8 group. Okay, and you have to do this control drill, and then you all have to present it to the class. Okay, so we take a 5-minute break before we continue. So in the meantime, slide in your attendance. So make sure you submit all the tutorial, okay, in the based on the example. Okay. Okay. For the control drill, make sure you also submit this. Submit all, not only one. So make sure you submit all. Try to do all of this exercise. Okay, group 1, you can start presenting your work. rewrite example 2 using switch case statement. Okay, show your screen. Okay, quickly, we don't have much time. Okay, present.
Okay, this is question question 1
Okay.
number 79 and then switch using switch. So yeah, that's the result. Tadi tadi.
Okay,
Kena
the
right.
Okay, run it.
So the answer is true. Yeah.
Okay, the
What
problem
one?
is, okay, let me share. Okay, if you do something like this, okay, so you have to be careful. Okay. Okay. So you have something like this. Okay, if you look here, if I said 79, okay, it's true. 1 is also true. 2 is also, 3 is also true. But the problem with your coding is that if you change other number, it can be problematic. Okay. So you have to flip it. Okay, I give you, for example, here, you assign a number here. Okay, just switch switch. For example, 4. Case. Okay. Case 0. Okay. Display false. You have to flip it. Okay, and then otherwise display true. Okay, why? Because if you look here, only 0 will show this. Okay, sorry. Okay, only 0 display false. Otherwise, if you display 1, 2, 3, 4, 5, it always display true. So for this case, you have to flip it, because if only display 0, okay, it will show this. Okay, let me write this. Okay, so it is true. 4, 5, 7. So always true, but only 0 will be displayed false. Okay, so okay, okay, something like this. Okay, only 0 will display false. So make sure you know how to convert and make sure the output is the same between this. Okay.
Okay. Kira there.
Sir,
Yes.
can I share my screen?
Okay. Okay. Share.
So, can you see that, sir?
Yeah, yes, I can see it.
All right. So, all right. For the example 2, I use this one.
Okay.
Right.
Wait. I check first. Example 2. The example 2.
Is example? Yes, I'm from group 1.
Oh, group 1 also. Okay.
Yes. All right.
What is this? You have to do example 2, right?
Yes. Using switch and case.
Okay.
Wait. So this is first one we enter the number.
Oh, you use something like this. You convert to logical.
Yes.
So for this case also you can. Okay, no need to flip.
Yeah.
Okay, so this one also correct.
Alright.
Okay, for programming there are a lot of way to do it. Okay, we continue with question 2. Yeah, I think no question 2 is quite a lot. Okay, I'll try. Isn't it? Okay, this is also a important skill you need to have. From code, you have to convert to flowchart. Okay, some of the question will ask this. Okay, group 2, present quickly.
Okay, wait. Is it? Sorry. Doctor, can you see my screen?
Yes, I can see.
Okay, so I'm from group 3, from group 2, and we got question number 2 that we have to draw flowchart for example 3, 4, and 5. This is for example 3. If you refer to the example 2, it start with the start and then you input the A, B, C value and then you insert inside the formula. If you get the D equals to 0 and also A is not equal to 0, if you get yes, you proceed with another formula and then you end the program. Same as if you didn't get this, the system will show display difference and then you end the program. Okay, for example 4 and 5, I will pass to my team.
Wait, you can see that you go to the end, right? Make sure it's all collect to one location.
Okay.
The display, after the display, different route
Mm-hmm.
goes to the arrow, not to the end. Okay, the arrow to the end. Okay?
Oh, okay. So it means that it went to here.
Yeah,
Oh, okay. Understood.
just standard practice.
Okay.
Okay,
Kita
next.
kira- Okay.
Okay.
Challenge.
And example 4. First start first and input ABC. After input, we will need to calculate the D if according to the question. And we do the
This is example 4, right?
yes, example 4. And if A is not equal to 0 for the decision, if yes, go to this. If no, go to this one. And for the equal to 0, if yes, we will do x1. And x2 is equal to x1. If no, we will find if it is greater than 0 or not. And this will be the two output. This is a little bit wrong because this has to be an arrow and that's all.
Okay, let me control your screen. Is it okay?
Yes.
Okay. For this conversion, you can see that D is equals to 0. Okay, N is equals to 0, right? Okay, wait. You have to approve the annotate. Can you okay. So this one you need to combine actually. These two needs to be combined together. Okay.
Okay.
So D is equals to 0 and A is not equals to 0. So so this one, okay, you have to combine. And then this one also you have to include both. Okay. You have to follow the code. Try to follow the code as close as possible.
Okay,
So,
okay.
and a not equal to 0. Okay. And this one, no, okay, correct. So goes down. Can you move it? I cannot move it. Okay, this one also you already mentioned, right? You forget to put this. Okay. So you have to put the arrow. So anything else is okay. So
Okay,
next. Okay, who will present? Example 5.
Sorry, doctor, but I think we haven't done example 5.
Oh, okay, okay. So the coding, the flowchart that you show, actually example 5. Okay. So that is the difference. Your flowchart show, your original flowchart that you show before is actually example 5. You split the if else, nested if. Okay. So actually that is the answer.
Sorry,
Okay.
doctor.
Yes.
I'm supposed to present example 5 from group 5.
Oh, it's okay.
I'm sorry.
Actually already presented before.
Oh, yeah ke? Okay.
That one is the answer. So you have to split. Can you show back that?
Me or the person before?
Person before.
Okay.
Okay, can you show it?
Con Cheng Yu.
It's okay, it's okay. I just show this. Okay, wait. So if you look here, example 5, so it split first. Okay, if A is not equal to 0, after that it will go 3 location. Okay. So you basically you have to follow the coding. So for this one, okay, for example 4, it's just 3 condition, but for this one, you have 1 condition, and then you split into 3. And as well, you forget to put this else. Okay, if A is not equal to 0, you go here, it's already correct, but else you have to put this. Okay, every time you have condition, make sure you have true and false. Yeah, when you use the what called rhombus, right? Forget already. Okay, continue with number 3. Question 3. So question 3 is, okay, I think this one no need. Okay, rewrite example 8. Okay, let me show. Okay, I think this one doesn't need because it's too simple. Okay, let me share first. Okay, so if you look here, the example 3, they want you to remove text 1 to 3. Okay, basically if you remove this, you get error. Okay, because you need text. Okay, text is created here. So basically it will display nothing. It will become error. Okay, the question is too simple. Okay, so how about example 4? Question 4. Write example 5 using logical vector. Okay, group 4.
Doctor, we still try it. We can't get the coding right yet.
Cannot write the coding, eh? Okay, let me see, eh? Okay, where is the share button? Okay, make sure you know the skill, eh? Try to know how to convert. Okay, so let me show you. Where is the question? So you can see here, rewrite example 5 using 4, sorry, 4. Logical vector method without using any decision statement. Okay, for this one, okay, of course you need to have ABC, eh? A is equal to 1 maybe, B is equal to 3, C equals to 4, for example. Okay, remember the logic is all the logic you have to example 5. Okay, so this is the statement. Okay, you have this is the statement, this is the statement, and this is the statement. So you have to copy all the logic. Okay, so for example here for this case, okay, so this is the logic, multiply this one, and don't forget n because you have two logic. So this one. Okay, copy the logic. How about this one also? The same. Okay, you have two logic. Okay, and you have to number this. So this one is condition A. How about condition 2? Of course, for condition 2, you have two logic also. This one, okay, so you have to multiply by this one and this one. Because you have two logic. So this one. Okay, for complex, look out back the question here. For also remove the complex condition contained display. Okay, for this case, just remove this. Okay, this one is ignore. So this one is condition B. Okay. So this one is another condition multiply by A is equals to 0. Okay, remember this is not equals to 0. This is equal to 0. Is it double or not? Okay. So you have all these condition, you already goes into it. So just remove if else. Okay, you already get this. And then you have to sum everything. So x1 is, because you have two conditions. So x1 is equals to x1a plus x1b. So for this condition, s1c plus x1c. Okay, x2 is equals to x2a plus x2b. Okay, so run this. So b squared minus 4ac b squared. So we start with the first condition, which is equal. Okay, b is equals to 0. So a is not there. Okay, b squared. Okay, so if I run this, x1. Okay, this one. Sorry. Okay, you get yx is 0. Okay, how about so this one? Oh, okay. Okay, so d is equal to 0. So automatically, this one is the logic here is 1, and the logic here is 1. So you just use this formula. So you get -2 and -2. Okay, how about this condition? Okay, you just run this. Okay, you get 2 root. Okay, it's only consider this. Because others, okay, this one becomes 0, this one becomes 0. Because d is more than 0. Okay, this is true, so it will become 1. So you just calculate this and this. Okay, how about c? So for c is when d is equals to 0. Okay, so okay. Oh, so for this case, okay, because this is none, it will also none. So I think this one you have to ignore lah. This one cannot be converted. Okay, just this. Okay, understand how to use this. Okay, understand how to use logic. Okay, logical vector. So just use this. Okay, next question 5. Yes, question 5.
Yes, I'll share my screen. Can you see? Okay.
Not yet.
Why?
Still no. Okay.
What about now? Okay.
Yes, yes.
So we change the if loop from this section. From this part, we switch to switch
Okay.
over here. And the output is the same once we run it. Like when d equals to 0, 1, 2, 1, we get case when d equals to 0, case 0, x1, x2 is the same. So we got both. Next is when d is more than 1. 1.
Yeah, the problem with your coding is number to cell. So how about 0 0.1, 0 0.2, 0 0.3? How you want to consider it?
We aren't really sure how to convert d to more than 0 into case. So we found this online and just follow it.
Yeah, this one is a little bit tricky. So that's why the question switch statement whenever possible. Okay, whenever possible, just otherwise, okay, just use this formula. Okay, display complex, no need to show. Okay,
Oh,
something like that.
okay.
Yeah, case 0. Okay, this one is correct. Then otherwise, this question. Okay,
Then
display
the complex root will not be
just
displayed lah.
yeah cannot be displayed because
Oh,
yeah the
okay.
problem with the example is not really good but it's okay. This one is acceptable. Only that one, the 0.1, 0.2, something like that, you cannot do this, right?
Oh, okay.
Okay.
Should I stop sharing now?
Yeah.
Okay, thank you, sir.
Okay, how about group 6?
Hello, doctor. Can you hear me?
Yes.
Okay, wait.
Doctor, see your screen.
Yes.
So this is our pseudo code for example 8. So first of
Okay.
all, we have to input the income, and then if income less or equal to 10,000, and then it will calculate the tax one, and then if income more than 10,000 and income less or equal to 20,000, it will calculate tax 2, and then if tax income more than 20,000, and then it will calculate the tax rate, and then it will end the decision, and then calculate the tax, and then it will display the tax. So the program will end.
Okay, what do you mean by return text?
No, it just the display text.
Okay. Okay, good. Next group 7.
Okay.
Hello, good morning, doctor.
Morning.
Alright.
Okay, this question a lot, right? So you can try?
Can you see my screen?
Yes.
Alright. This is example 11, and we need to do example for question 7. We need to do flow charts for example 11, 12, 13, and 14. So for example 11, flow chart. So we start and then we declare the variables. Then we do the condition. For q is less than or equals to 2. If
Okay.
false, then we direct this to stop. Then this is the process. And then lastly, in the parallelogram or rhombus, we display Q and T.
Okay. Wait. So this one, okay. Can I have this annotate?
Yes.
Okay. So this one is just a process. So you can just use one block.
Oh, right.
Okay. So easier.
Okay.
Okay. No need
Alright.
to multiple block. You just
Alright,
combine
okay.
it. Okay. And then display is actually when the loop ends. Okay. So this one, this arrow is wrong.
Oh, yeah. Okay.
Yes. And the location is also wrong. So this one is actually, wait, how to delete this? Oh. Okay. So actually here, okay.
Okay.
Okay, wait. Okay, this one, disconnect. Okay, this one will go to here. Oops, sorry. This one will go to here. Okay, arrow. Okay, this is true. And false. Okay, this one will go here. Okay.
Alright, okay.
So be careful,
Alright.
Okay, next.
For example
12. Example 12.
Good morning, doctor.
Okay, morning.
Let me share my screen first. Bro Ziley, can you? Thank
Right.
you, bro. Love you, bro.
All right. Love you too.
Out. So this is our coding. Wait, let me look at the question. Rewrite example 14 by replacing the word try. To try is when the number of try is greater than 1. So
Number 7.
oh,
Okay,
oh,
number 7, there are example 12, 13, right?
sorry,
Yeah.
Zali. I messed up.
Ah.
Alright, Zali, take it back. Sorry, bro.
Okay.
Okay.
All right. For example 12, Kasha will explain it.
Okay, for example 12, I have just realized I made a mistake, but I will continue to explain. So start input 0.08, r equals 0.08, and then there is a condition a equals to 100, 500, 800. So when it is true, it will continue. If it is false, it will end. But I forgot to put the display a equals to I forgot to do that, so include that in there. So next is the other condition, n equals to 2.2210, and next is the process b equals to a multiplied by 1 plus r power n, and then display, and it should be an arrow from display to the end.
Okay, and the problem is you cannot use index as true or false, right? Okay. Understand what I'm trying to say? You see here, you in the true false shape. Okay, the rhombus, right? It's called. Okay, you have a is equals to 100, 500, 800. So how you know it is true or false? It's just a vector. So n is equal to 2 until 10. It's also just a vector. So this one cannot, you cannot use something like this. Okay, I will share the screen. Okay. Wait. Okay, if you look here, so you have start, and then goes to the input. Okay, this one can be input or process. Okay, r equals to 0.08. Okay, and then, so for this one, you have to set. Okay, you cannot just write directly. So you need to set a equals to 100, 500, 800. Okay, so n is equals to 2 to 10. So, and you need to show a new parameter. Okay, let me make this larger. Okay, for this case, it's quite difficult to just directly convert for function. Okay. So of course you have to create a something like this. A is equals to 100, 500, 800, and is equals to 2 to 10, and then you have to create a new parameter x is equals to 1, y is equals to 1. Okay. So then you look for the first parameter. Okay. Okay, there is two ways to do this. So for this case is as long as this one the data is increasing, so you just said that a is less than or equal to 800. Okay. Or another way, okay, you use assign this x with a, y with n. Okay. So for this case, x is less than or equal to 3, means because you have 1, 2, 3, 3 data. So x is less than 3, and then again, you have another data. This one is yes. Okay. And then, oh, forget display. So you have to display A. Okay, for this case, you have to display A x. Okay, for this case. Okay, so this is yes, and then same here. Okay, A. Oh, sorry, no. If y is less than or equals to, you have 10 data, right? 2, 4, 6, 8, 10. 5 data. Okay. Okay, and then show B. You calculate B equals to something. Okay. Okay, for this one is a little bit tedious, so make sure you be careful. So of course you have to display N and B. So display N and B. Okay, display N and B. And then at the end you have to add. Okay. And oh sorry. Y equals to Y plus 1. And then it will goes to here. Okay. So this one, okay, this one is yes. And then no. It will go, okay. If no, it will go to this one. You have to add x equals to x plus 1. Okay, because you are the end of this, you have to add 1 here. Okay, at the end you have to add 1. On you have to go to this, correct? Okay, and then this one will end. Okay, something like this. Okay, can you understand it? It's a little bit tricky because you are involved with index. So you have to introduce a new parameter, which is the location of the index. Location of index. Okay. There is no other way around. I try to find another easier way to do this, but in the meantime, you try to do using this method. Okay. So next example.
Okay, doctor. I'm not sure whether my answer is correct because none of my group members can do as well as me, but I'm gonna share anyway.
Okay, good.
Can you see?
Okay.
So this is what we did. Just add 3, 6, 9, and then I tested value one by one, 3, 6, 9, and then it's all the same values. So I'm not sure whether it's correct or not.
This one is what? Question 8.
Question 8, yeah.
Oh, sorry. 7 also still not finished, right? Example 14.
Oh, really? Oh, sorry.
It's okay. It's okay. So
Oh,
example 14.
sorry.
Yeah.
Stop.
Some group have a lot of question. It's not balanced actually for the drill. Okay, you do it or not? Where is group 7?
Yes, doctor. I
Yeah.
disconnected just now.
Okay.
So I will continue with example 13.
13 or 14?
Until 14.
Oh,
Just now
13.
12.
Okay.
Alright.
Okay.
So Renat will present about example 13.
Yes, good morning, doctor.
Morning.
So this is example 13.
Okay.
So for example 13, first we initialize the number n equals to 0, and we increase the number n by 1. After that, we make a decision to decide whether is there any remainder when the number n divided by 7. In short, when the number n is not divisible by 7, the counter will increase. That means the number of n will keep on increasing until the number n is divisible by 7, means there is no remainder. If there is no remainder, then the code will display the number n, and it will make a decision again to decide whether the number of n is larger than 50 or not. If it is larger than 50, then the code will end, or if the number of n is still less than 50 or in between 1 and 50, then the loop will still repeat. So
Okay.
that's all.
I think okay, correct. Okay, next example 14.
Thank you, doctor.
Okay, welcome.
Hello, doctor.
Okay, hello.
Okay, first, this is example 14. First start, then we initialize x equals to randy 6, n is equal to 0. Then it will go to the decision while 1, which is always true. Then it will ask the user to guess the input. Then n equals to n plus 1. If the guess is equals to x, which is true, it will display you got it right after n try. If false, it will go upwards to execute the loop back.
Wait.
Tu je.
Okay, the while at the top, no need to put.
Oh, okay.
Okay. So it's redundant actually. Remember that I said that anything that is that shape, the rhombus shape, right? Okay. So that shape, you need to have yes and no, true or false. Okay, this one you can see it is nothing, right? It's no, only true. So that one just can be ignored.
Oh, okay. But the sudo code display while one tu tak payah tulis
No
dalam
need.
chat.
Sometimes the flowchart and the code is not very similar, but you have to do as close as possible.
Alright, thank you, doctor.
Okay, welcome. Okay, next group 8.
Yeah, okay, hold on, doctor.
Okay.
Can see?
Okay.
Yeah, this is the one lah. Basically, we don't know how to do, but I'm just gonna present anyway. So yeah lah, this is our code. This is how we write example 11. So we just run and we get answer. I don't know how to display it as long with the voltage.
Okay. Can you tell me what you write?
So originally it was just voltage 9 as per the example, but so what we did was we just added 3, 6, and 9.
Okay.
And then instead of putting display Q, the long one, we just we just shorten it lah into QT and then just run and we get answer.
Should be one by one, right?
Yeah, that's why I'm not sure also because when I check one by one, 3, 6, 9, all the answers are similar. So I'm thinking maybe this is the correct answer lah. So
Okay. Can I have the control?
sure, no problem.
Okay. When it comes to multiple parameter, they don't specify, right? What method you have to use. There are a lot of method you can use, but for this one, okay, this one you just call the location.
Okay.
Oh, sorry. I used a wrong. Should be this one. Okay. Okay, and okay, you already do this, correct?
Hmm?
Okay, and for this one, okay, I suggest you put here. Okay, because you have to display three time, right?
Yeah. Yeah.
So then you have you have three. Okay, you have three parameter. So instead of using dot, you just use the location. Okay, something like this.
Okay.
Okay, and then of course you need to display the voltage. Okay, something like this. Okay, run it. Why? Can I clear this?
Yeah, sure. Boom.
Why nothing happened? Oh. Okay. Sorry. So for this one, quite difficult. Okay. So for this one, you have to okay, let me check my answer.
So should I stop sharing?
Yeah, stop sharing.
Okay. I have no control over my computer.
Oh,
Okay, now.
okay.
All right.
Okay.
Now, thank you.
Okay. So this is question 8, right? Question 8. So, I'm using double wire. This one, right? Wait.
Yeah, this one.
Yeah, I'm using double wire. So for this case, I just assume that the voltage is less than 9 because 3, 6, 9, right?
Yes,
Okay,
yes.
so I just add it. Okay, display the voltage and then just add it. Okay, this is the one way to do this. There actually you can use 4 and the metric. Okay, depend on you because the question doesn't specify anything, right?
The question specify 3-row matrix. Yeah. Matrix with 3 rows.
3. Yeah, should be this one also you also can get the answer. Okay.
Okay,
See?
I see. Thank you.
So V3, you get the answer. V6, you get the answer. Okay, and V9, you get the answer.
Okay, thank you, thank you.
Okay. So I think this question is not too specific, so you can use any way you can.
All right, thank you.
Okay. We don't have time anymore, so you can try to do example 9 until 16. Okay. Try to do this and submit with the tutorial. Submit with the example 11, right? Example 11 until 18. Okay, try to submit it. Okay, okay, replacing while. Okay, I think this one is not too difficult. Okay, you can try. Okay, this one is a bit difficult. Yeah, you can try it. Okay, I will share the code. Okay, in the group. Okay. Okay. If there is no more question, I will end the class. Okay. Thank you. Yes.
Doctor,
Yes.
for control flow, the control flow drill, number 1 to 8, we don't need to do.
Also do.
Okay.
Just practice. I just want you to see how it works. Okay.
Okay, thank you, Doctor.
Okay. Welcome. Okay. Any more question?
No, Doctor.
Okay. So thank you.
Thank you, doctor.
Have a good day.
Thank you, Doctor.
Bye bye.
Okay. Welcome.
Thank you, Doctor.
Okay. Welcome.
Thank you.